Hi guys, this is Mr. Urrego. Welcome back to our series Beat the Test. We're going to review for our geometry and of course exam. Let's work on question number 27. So first of all, let's read the question. A traffic camera sits on the top of a tower that has a height of 50 feet. The angles of depression of two cars on a straight row at the same level as the base of the tower and on the same side of it are 25 degrees and 40 degrees. Calculate the distance between the two cars. Alright, cool. So here we go. So I drew some kind of information already ahead of time. So this is my tower. This is the camera on the top. Alright, let me get a pencil and get a straight line. Pencil, let's do this with blue. Oh, let's get a straight line. Here we go. So the camera, this is the car. Alright, this is one of the cars. This is the second car. Here we go. That's why I have two triangles on the left side. Alright, the angles of depression. So let's talk about the angles of depression. So the angles of depression are the angles that are made with the horizontal. So let me get a different color with the horizontal. So this is the camera. I'm going to put a horizontal line right there. Okay, horizontal line. So let me read the problem again, so you understand what's going on. And let me get something. Let's get black, for example. All right. So a traffic camera sits on top of a tower. Here's the camera, right? This is the camera. 50 feet. So the height here is 50. All right, that's 50 feet. The top of the camera, right here, the top, 50 feet. The angles of depression of two cars on a straight row are at the same level. So angles of depression. So here's the camera. Because the camera is looking down, that's why it's called angle of depression. Because the camera is looking down. So one of the angles is 25 and the other one is 40. So this one is 40 degrees. And the other one is 25 degrees. Right? Smaller angle. Those are the angles of depression from the horizontal to where the camera is looking at the car. Okay, so the camera is looking at this car, and my angle of depression is 40 from the horizontal. All right, the camera is looking at the second car. All right, they're saying they're on the same side of the camera. Okay, so and this one is 25 degrees, smaller the angle. Why? Because the car is further away. All right. The question, what is the question? Calculate this is the two cars. So they're asking me for this. How much is this between the two cars? Interesting. What do I do? Okay, so here we go. We have those angles. All right, we got to play with those angles and we got to play with triangles. That's the whole idea. When they give me one side and angles, this is trig. Right there, we're talking about trigonometry. All right, which means we're doing SOHCAHTOA, sine, cosine, and tangent. So I don't know which one we're doing. Tangent is adjacent. Hold on. SOHCAHTOA. This is an O. All right. Sine is opposite of hypotenuse. Cosine is opposite of hypotenuse. Tangent is opposite of adjacent. I gotta use one of those three. Sine, cosine, or tangent. Which one? I have no idea. It depends on what the information is given. So let's translate. So how do I get from here to here? Okay, so let's work on the first triangle here, on the little one, the first car right here. Okay, so guys, the idea is the following. Look, this is our plan. I need to find this distance. Okay, but there's no information or there's no magic thing that in one step I can get to here. So what I plan to do is I want to know how much is this distance, the bottom of this. I want to find how much that. Let's call that whatever. Let's call that A. That A is this A. Right? Is my first triangle. Okay? This angle on the top, okay, because this line is horizontal and the floor is horizontal, those lines are parallel to each other. Therefore, that angle is the same as this angle, and they're called alternate interior angles. And this is, if that's 40, that's 40. So this triangle is this first triangle that I have here. So this angle is 40 degrees. That's a horrible 40, but it's a 40. So let me try to write it again. Make it bigger. 40 degrees. All right? Angle depression is 40. Is the same as the one in the inside because alternate interior angles. Got it. What else do I know? Oh, the 50. They gave me the 50. That's how high is the camera. Where is that thing? This is the 50, the vertical piece. Therefore, this is 50. Got it. So that's how I translated this information into one triangle. I got to work with right triangles because I'm going to do trig. All right. Let's do the same with the second triangle. Okay? Now, again, remember, I want to find the distance between the two of them. Let me call the whole thing. Actually, let me call the whole thing. The whole thing, let me call that B. So that B is my big triangle. This is B, the big triangle. If this angle on the top is 25, this angle here is 25. Therefore, this angle is 25 degrees. Why? Alternate interior angles because the top and the bottom are parallel lines. That's 25, that's 25. I got my angle 25. What else do I have? I have the 50 as well because that's where my camera is sitting down. So this is 50. And I got my information from my word problem into two triangles. What's going to happen? How do I find x? Guess what? X is B, the whole thing, minus A. So if I find A and B, I subtracted them, and I'm going to find the distance between the two cars. And that's the answer. So that's our plan. Every time you read a word problem, you got to make a plan. You got to find out what are you using, and then go for it. I got my two triangles. Now this is the easy part. The hard part was what we just did. So let's do the easy part. Now I have my first triangle. I got to find the value of A. Whenever I have an angle and I have one side, I have to think, if this is if this is a right triangle, I got it trigonometry. Okay, so guys, this side is your hypotenuse. Am I using my hypotenuses in these problems at all? No, I need the A, I have the 50, I have the 40. So I'm not using my hypotenuse whatsoever. So whatever hypotenuse here, I'm not using it. The sine has a hypotenuse. I'm not using sine. The cosine has a hypotenuse. I'm not using cosine. I'm using tangent because tangent is opposite over adjacent. Tangent of what? Tangent of my angle. So let me get into, I guess, purple or something. Let me get what? I guess blue. Let's do it blue. So tangent of my angle. Oh, why black? Tangent of my angle. Tangent of my angle. Let me get blue. Here we go. Tangent of my angle. What was my angle? My angle is 40. It's equal to, tangent is equal to opposite side over adjacent side. Opposite. 40. Opposite is across. So opposite to the angle 40 is 50. So let me write it first. Opposite over adjacent. Tangent of 40. Opposite. What's opposite? Across. This is the angle. Make a line across the triangle. That's opposite, which is 50. Over adjacent. Adjacent is whatever is next to the angle. Not your hypotenuse. The other side, which is A. Let's leave the A by itself. That means I have to do some cross multiplication. I'm going to put a fraction this, and I'm going to do some cross multiplication. A times tangent of 40. A times tangent of 40 equals the other diagonal, which is 50 times 1, which is 50. Let's leave the a by itself. I gotta divide by tangent of 40 on both sides. Tangent of 40 on both sides. The tangent and tangent, they cancel out, and I have a equals 50 over tangent of 40. Tangent of 40. And now I gotta plug this into a calculator. We gotta plug this into the calculator, and don't forget, it has to be with degrees. So what is this? 50 divided by tangent of 40, and that's gonna give me 59.59 feet. And I have this one. Now let's go and find the same thing, the same process with B. So change color, red or pink, whatever. Same process, tangent of my angle, which is 25, is equal to opposite side, which is 50, divided by my adjacent. Adjacent is next to the angle, which is B. I need to work this out, so I make this a fraction. And now I need to do cross multiplication. Cross multiplication is this diagonal. B times tangent of 25. B times tangent of 25. That's called cross multiplication. And that's going to be equal to the other diagonal, which is 50 times 1, which is 50. I need to leave the B by itself. Divide by tangent of 25 on both sides. That's why we need to know how to work with the equations. Tangent 25 cancel out, and I have B equals 50 divided by tangent of 25. Whenever you're putting this into a calculator, make sure your calculator is on degrees. 50 divided by tangent of 25, I have it here, is 107.23. Oh my God, that's a horrible 20. Whoa, horrible. 23. Okay, so 0.23 feet, because those are my units. What did I say in the beginning? My x value is the whole thing, which is b minus this piece. X, which is the distance between the right? Distance between the cars, I'm going to call that x, is 107.23 minus 59.59, which is going to give me 47.64. You can stop the video and do the math by yourselves. That's the idea, obviously. So the distance between the two cars is 47.64 feet. Okay? A lot of information, guys. A lot of information. The main idea is the beginning. This is the biggest part of the whole problem. Is translating that information that you have here into a drawing. Is understanding that an angle of depression is looking down. Okay? It's understanding an angle of depression has a horizontal line always. So that's the most important part of this problem. Okay? Translating the information from here to a drawing. And then identifying what am I using. Again, every time you have an angle and a height, you got to use trig. All right? So I hope that helps. Guys, again, if you find it helpful, please like the video, subscribe to the channel. We're going to finish the whole series. It's 52 questions. This is question 27. Here you go. Thank you for watching.